Welcome back to the Formulaic Approach channel. Let's talk about the Markovnikov's rule, otherwise spelled as Markovnikov with the double F and with W here. Okay, all right. Now, what is this about? Now, the Markovnikov rule is about the addition of hydrogen halide to an alkene. Okay, one of the chemical reactions for alkene. So when you want to add an hydrogen halide to an alkene, it follows the Markovnikov's rule. Okay, now what does the Markovnikov rule say? You want to add this, we say hydrohalogenate. Okay, the process is called hydrohalogenation. Okay, so you want to hydrohalogenate. So for example, our alkene is like this. Let's say this is our alkene chain, our alkene skeleton, and you want to add HBr, for example. Now, what does the Markovnikov rule say? The Markovnikov rule says that hydrogen between this and this, which one is bulky or larger? This molecule is larger than this. So it says that the larger molecule should be added to the one that has less hydrogen, while the hydrogen should be added to the molecule, to the carbon that has more hydrogen. So what do we want to do here? So these are hydrogens around the hydrogens, around the hydrogens, around the hydrogens, hydrogens. So we want to add HBr. We want to break the pi bond, right? So on breaking the pi bond, is either we add hydrogen here and add bromine here, or add bromine here and add hydrogen here. That's what we want to do. Bromine here, hydrogen here. That's what we want to do. Markovnikov rule says that you should add this bulky group to the side that is bulky. And what do you mean by the side by bulky? That is the carbon that has the most substitution. Okay, that's just big grammar. The simplistic thing is that this guy has less hydrogen. That's only one hydrogen, right? So you will give it bromine. This one that has more hydrogen. Think of hydrogen wanting to go and meet his friend. Okay, so this one will take hydrogen. So your answer, the product you will get, the Markovnikov product is this guy bonded. This guy will be bonded to. So I'm not sure these ones that I'm not showing the skeleton is the hydrogens and the group that I already have. So, but the one I will show is the products now. And you see, this carbon is having less hydrogen, so it will get the Br. Hydrogen will not come to where carbon is less. Think where hydrogen is less. So this guy C that has more hydrogen is going to get the hydrogen. Do you understand now? So it means these other hydrogen, these are the groups attached now. These other ones here. They are implied if it's not drawn, okay? They are implied. Well, here are the groups now. You notice that the hydrogen came to the guy with more hydrogen. Think of this hydrogen thinking like, I can't come to you because why do you not have more children? Says, can't say anything. Okay, so the hydrogen assumes it's because it's wicked. Okay, so this carbon now says, okay, there's no problem. Then this bromine says, I will go to him. Then he goes to him. Then this one sees his friend many here. So things like they're enjoying. So he goes to this guy. Does that make sense? All right, so that's Markovnikov rule. When you want to add hydrogen halide, add the halide to the carbon that is more substituted, the carbon that has more carbon around it. Add the halide to it. Okay, the halide are the chlorine, bromine, fluorine, aspartame, iodine, etc. Add the halide to that carbon that has more carbon around it. Then add hydrogen to the carbon that has more hydrogen around it. Does that make sense? Okay. Now let's talk about the Karask effect. Now first, let me tell you why it happens like this. The reason why it happens like this is because for the formation of the haloalkane that is to be formed there, what we form is a haloalkane. The product is always a haloalkane. Now, the mechanism that follows this haloalkane is a mechanism that requires a carbocation. Okay, it requires what? A carbocation. We call it this mechanism an electrophilic addition. an electrophilic addition. So it requires the formation of a carbocation as an intermediate product. A carbocation, like I've said before, is a carbon that bears a positive charge. So for that carbocation to be stable, it needs to be around, to have bulky group around it. Okay, so because of that, it will, need to be so this bulky group will have to now go to that place where there's what? A carbocation formation. Because the bulky group is going to be negative. The halide is negative. So, and carbocation is positive, so they attract each other. Does that make sense? So, what is basically chemically doing is that this guy is bringing electron to an electron deficient center, okay? So because of that, for that electron deficient center to actually be formed at all, it has to be formed by a carbon that has what? Electron higher substitution around it. But the Karasky effect is the one that gives us, so this is called the Markovnikov product, okay? The Markovnikov product. But the Karasky effect, also called peroxide effect, okay, was discovered by two scientists, Karask and Mayo. This guy, Karask and Mayo, okay? So these two guys found that in the presence of a peroxide, that this is not the case. In the presence of a peroxide, actually, what will be formed is the opposite of this, which we call the anti-Markovnikov. So this will be the Markov. Now the way you can also see it being spelled is like this. This will be the Markovnikov product. But in the presence of a peroxide, in the presence of a peroxide, what will happen is the opposite of this. Remember that in this case for Markovnikov, this guy wants to go with more hydrogen, which will reverse the order. This one will go to this place so that we have CH3 bonded to CH, our new H will be here, and Br will be here. Now the reason is because, the reason for this one, you remember that this one I said that the ones that I put in brackets in circle here are the new guys, okay? So notice that the hydrogen comes to the carbon that has less hydrogen, and the bromine comes to the carbon that has more hydrogen. This is called the anti-Markovnikov product. Does that make sense now? So this is the reason. You know this one, the reason is because of the formation of the carbocation intermediate. In this case, the reason is because the mechanism in the presence of a peroxide proceeds by a free radical mechanism. I'm going to expatiate this. I'm going to expatiate on this when we begin to talk about mechanism of reaction in full. So that is the reason. So that is what we have for Markovnikov and anti-Markovnikov. Do well to subscribe to the channel. God bless you.